Oh yeah, can you show me some trees and graphs? Yeah, because if that's before I know how
Uh,
to plan my next sessions.
right. I haven't done really like a lot of problems with. This was a three. I think this was the only three problem I have done. I
Okay.
haven't like,
Okay.
and we used like DFS to uh, what was it? Uh,
Depth first search.
yeah, uh, I have shown you
Adjacency.
this problem. I think so. I think.
Okay. Adjacency. Okay. Yeah. This is what I wanted to see. Um, do you have another graph problem, or is this the only one that you have seen?
Uh, wait. This is yeah.
Is
We
another
have
one?
done that. It's not a problem with graphs, right? We have done that. Uh, not really. Definitely not. Oh, it's this was like a problem to check if a graph is a cycle, but yeah,
Okay.
that's it. Yeah.
Okay. I understand now. I understand. Okay, so I know what to do now. All right, you can stop sharing your screen now.
Okay.
I'm gonna join the thing. Okay. I'll explain why I wanted to see that probably sometime later. Let's first cover what we did last time, because I think last time we left off on a problem, right?
I did that in my free time.
Wow. Wait, did you actually finish it after our session last time?
Yeah.
Damn, okay, man of your word. All right. So I'm joining your thing. Sunrise. Let me share my screen. The recording started.
Mhm. It was it was like not not hard, but interesting, right? It
Find
was
path.
interesting.
Okay, let's see.
Like I just had to learn like the option.
Okay. Option list number. So yeah, line 354 isn't necessary anymore, right? Because the signature is already
Yeah.
embedded in the function header. Okay, let's say leave to none. Otherwise, if it's a node, sub list value. Otherwise, cases option, find path to root, left target.
If it's return something, I will like add it to uh current list with a value that's right now. But
Okay. This is one of the solutions, but is this O of is this what is this O of n?
hmm,
Actually, wait.
this is DFS, right?
I think it is O of n. So yeah, can you explain to me, is it O of n and why?
Uh, mm, wait. Hmm. Yeah. Uh, it is O of N, I think.
Okay.
I think it is O of like uh nodes, right?
Yeah. Okay. I do believe this is O of n, but we're paying an incredible cost appending to the end of the list.
Okay.
You see that? What's another way of dealing with this so that we don't append to the end of the list?
Hmm.
So does this sound familiar? Paying every time we iterate, we are adding to the end of the list, and every time we do that, it gets more and more expensive.
Kinda.
Okay, where did we last hear this?
Wait. w- Okay, can you say that again? I don't.
So every time we step into the tree, one level deeper, we are aggregating our list, right? Our list is getting longer.
Yeah.
And every time we want to add to the end of that list, it is expensive, right? We have to go through the back
Hmm.
of the list to add the thing.
Right.
We've done this before with lists. Where did we last done this? Where we kept adding to the back of the list.
In lists or
Yep.
in trees?
In list. We were working on a list problem in the past.
Really?
Yep.
Ah,
Okay, to be
hmm.
fair for you, your first solution used the accumulator. Then I asked us to write without the accumulator, and it was a worse performance. Do you remember
Oh,
that?
like reverse, yeah.
Reverse, exactly.
Yeah.
You see the reverse problem here? It's the same thing, right?
Yeah, yeah, kinda. Okay.
Yeah. It- It's
Hmm.
reverse in the sense that I want the path from bottom to top, but naturally, we are going to see from top to bottom as we go downwards, right?
Yeah.
And so you're having to like append to the end of the list. But similarly to what we did in reverse, how do we do it so that we didn't have to keep appending to the end of the list?
Hmm. Ah, wait. Hmm. So, like, we can like use an accumulator, right?
Yes, yeah.
Hmm. Okay.
Okay, so I don't think I'll ask you to do it now. Maybe I'll ask you to do it at your own time. But this accumulator, what's the? Remember, we have to answer 4 questions about it.
Yeah.
What are the 4 things about this accumulator?
Hmm.
So what's the first
Uh,
question?
what was the questions about the accumulators? What does it represent? I think.
Yep. What does it
Yes.
represent?
Uh,
What's the second one?
hmm. Where? Okay. Uh, what does it represent? Uh, like
Okay.
like like nodes that we found from like root to the current like node, right?
Hmm. Okay. I would say it's actually the opposite.
Okay.
The thing we are accumulating is the path from our current node to the root. Because whenever we go one level deeper,
Okay.
we,
Yeah.
we take the value we just seen and put it at the
Mm.
top of the accumulator,
Mm.
right? Um, what are the other questions of an accumulator that we must answer?
Uh, what is it? What's its initial value, right?
Yeah.
Mm,
So in the case of our accumulator, what would it be?
hmm. Like empty, right?
Empty. Okay.
Okay.
I mean, we haven't gotten any values yet, right? So that's the only
Yeah,
possible
yeah.
value to start with. Okay, what's the next question?
How does it change?
How does it change? Okay. So how does our accumulator change?
Uh, like at each step, like we add like the uh, root of our like node, right?
Yeah. Well, specifically its value, the value of the
Yeah,
current node, right? Yeah.
yeah, yeah. Sorry.
What's the last question?
How is it useful
How's it? So yeah, how's it useful?
that we don't have to like use append, right? We don't have
Yeah.
to append to the end.
Do you know the
We
story of,
like,
yeah?
yeah, you can.
Do you know the story of Hansel and Gretel?
I don't think so.
It's like two kids. They were leaving home and they left breadcrumbs on the ground to remember how to get home.
Okay.
Wait, have you heard of this story?
No, no,
Oh, bro, what are you
definitely
teaching
not.
kids these days, man? Okay, yeah, dude, that's like a classic, man. It's a classic. So yeah,
Maybe in like USA, but
no, dude, this story is. I don't even think it's like. I think it's somewhere it's a European story if I'm not wrong. Like the names are
really,
pretty European. Okay, anyway. So yeah, that's a story. Two children. It's a pretty dark story, but the key idea here is they leave breadcrumbs as they leave home, and so to remember,
wait, what
yeah,
was the name of the story?
Hansel and Gretel.
Mm. Oh, okay, okay.
Goes by a different Polish name, I'm guessing.
Yeah, like so different.
So
So
different,
different.
really. Okay,
Yeah,
what is it in Polish?
you don't want to know.
Like,
Okay,
does it start?
it's it's Jaś i Małgosia.
Okay, the second one sounds similar, but the first one is completely different.
Yeah, it's like
Okay.
mm,
So yeah,
okay, it's a German story,
German.
okay.
Okay.
German, yeah.
Oh yeah, I guess Hansel and Gretel does sound like German names.
Yeah,
Yeah.
yeah.
Okay, yeah, okay. So okay, you do know about it. But yeah, as they leave home, they leave
Yeah.
breadcrumbs, right?
Yeah.
And it's the same thing that's happening here. As we leave the root of the tree, we're leaving, not to say we're leaving breadcrumbs, but we're like, instead of leaving something behind, we're taking the node value with us, right?
Yeah.
And so if we trace from the start of our accumulator to its end, it's like following the breadcrumbs back home.
Mm.
Um, yeah. So the information that is very useful is where we were just at, and so that's precisely the information we're keeping track of. It's like, oh, we were just here, let's save that. We were just here. Oh, we were just here, let's put that in our accumulator.
Okay.
Yeah, okay.
Yeah.
That's
This
an
was
important.
yeah. This is like mid-level, not very hard, but it's mid,
I
I would say.
Yeah, yeah. The reason why I introduced this problem, I wanted to introduce you into accumulators with trees,
Okay.
but I think we're going to move on because I was that's why I asked you how they did graph problems. I actually want to move to graphs first, and then we'll come
Mm.
back to trees. So I think I'm doing this a little bit differently than how I would normally do it. So we're gonna go to
Okay.
graphs. I think I'll create a new file for this. Okay. So the plan is I'm going to introduce us to graphs. So I'll create a new file called graphs.arr, and then we'll do some operations on graphs. Then we'll go back to trees, and then we'll go back to graphs, and then we'll go into algorithms,
Okay.
like harder algorithms. Okay, so graphs.
Like what algorithms?
For example, have you heard like dynamic programming?
Yeah,
That
I
that
yeah.
that's the probably the most important one that you'll need.
Okay.
Because yeah, I saw some dynamic programming problems. And the thing,
Mm,
dynamic programming is one of those things where like if you have never learned it before and you get those problems, those problems are very hard. But
okay.
once you learn the technique, the problems become very easy because you're just following a formula.
Okay.
That's why I want you to get you there. But for
Can we
now,
have like
mhm.
can we have like an one session that is like made for like easy algorithms like I don't know, two pointers or binary search, something like that.
uh
Just to like remind me of them.
soon. I would say it's
Okay.
more useful to because I need to flesh out your fundamentals with graphs first.
Okay. Okay.
2 point, but okay, binary search you basically already know it.
Yeah, but
Uh,
yeah.
and for 2 pointers, I think we work on graphs first, and then I will probably talk a little bit about 2 pointers. 2 pointers is
Okay.
essentially accumulators. Two accumulators. Each accumulator is a pointer.
Yeah,
Uh, yeah, we can talk a little bit about that. But yeah, we'll get there eventually. Let's talk about graphs first.
of course.
Actually, I think
Yeah.
I think it's better to do this on Excalibur. I need to draw some graphs. So let's move over. I'm gonna once again create a session.
Can I just like join the last session? Wait.
I killed it.
Oh, okay.
Yeah, it's not permanent. I will send it to Zoom chat.
Mm, my whiteboard doesn't do that. It doesn't kill the sessions.
Oh, I think I can leave it on, but I usually like at the end of sessions I
Oh,
usually
okay.
kill it. Yeah,
Okay.
because I don't want to come back
Oh,
and like what happened to my session? Like everything's destroyed.
all right.
It's kind of satisfying to group everything. Okay, let's go to the farthest right. Okay, and then I'm gonna share my screen on the whiteboard. So back to fundamentals. I don't emphasize this with you, I emphasize this with everyone else, but the central idea behind programming is the relationship between information and data. Do you remember that?
Yeah.
Well, that's small. Okay, zoom in until the information looks like normal size.
Okay.
Okay, so I'm gonna first show you information. Don't worry about data yet. So let's say we are doing a, let's say we are creating a social media app like Twitter. Let's call it Z. We're creating a social media app that's Z that's based on Twitter. Okay, it looks like it's basically Twitter. So in Twitter, are you familiar with Twitter?
Like X, right?
Oh yeah, X, yeah.
Yeah,
Yeah, that's
yeah.
where I got a Z from. I took X, Y, Z. I didn't want to go with Y because it sounds like WHY.
Oh, okay.
So so let's say we have these circles and each circle is a person. I'm not gonna name them.
Yeah.
No, I have to name them. I need to name them. So let's say that's the names, let's keep it short, A, B, C, D. So in our social media, one person can follow another person. So it's not bi-directional, right? A can follow B, but B doesn't have to follow A. Okay?
Right.
So to represent this relationship with my graph, I'll say that the tail of the arrow is who's being followed. So this arrow here means A is following B. Okay?
Yeah, makes sense.
So let's say B is very popular. B is a celebrity. A and C are following B. Let's say
Okay.
D created an account and forgot about it. So they are not related to anyone. And let's
Mm,
say B and C are friends. So we have
mm.
C here. And let's say let's have one more person here, E. And let's say E is the queen of, sorry, I can't say it anymore. It's the, I don't know,
Were you trying to like
it's the prime
talk
minister of a
about the
country.
Queen of England?
Yeah, I was about to say that.
Mm,
It just occurred to me, it's like, oh wait, never mind.
unlucky.
Yeah. Okay. Let's say it's the king of, it's a prime minister of a country. Okay.
Okay. Of Poland, right?
Oh, okay. Yeah, let's say the prime minister of Poland. Okay, so B follows E, and the prime minister of Poland, They don't follow anyone. They're just using their social media to just post stuff. Okay?
Okay.
All right, so they don't follow anyone. Um, great. So here we have information. We're not talking about computer stuff, right? This is literally information.
Yeah.
This is okay, it's a graph. Okay, I'm not gonna lie to you anymore. It's a graph. Why is this a graph?
Are you asking me?
Hmm. I mean, you've done stuff with graphs, so why is this a graph?
Mm, because we have like nodes and edges, right?
Okay, yeah. So in mathematics, that's basically the definition of a graph. You have nodes and things that connect nodes, and we call them edges. This
Yeah.
is a very simple idea that has very deep consequences, which is why mathematicians study graphs as mathematical objects.
Mm.
But we are computer people. We're not going to study the mathematical properties of graphs. If you do like college level mathematical competitive programming, you probably have to do that, but that's not our case here. For us, we just need to process this information. In order to process this as information, we need to turn this into data. How are we going to turn this into data?
Hmm. Is this a question?
Yes. How do we turn this into
Okay,
data?
so like the simplest idea is that we make a list for of like the persons that the people that he is like following
Okay. Can you write
and
this
so
out?
on.
Yeah, can you write this out for this specific graph? Can you show me what you mean?
Of course.
Okay. Okay. I'm going to move this to the left because it's
Okay.
below information data thing, which I think is cool. All right. Let me see if this is right. A to B, if B is following C and E, C is following B, D is alone, E is also alone. Good, good, good. And no one references D, so looks right. Okay, can you write the data representation of this in like the data definition? So this is a specific example. How do we write this more generally?
What? So
Okay, you know what? I'll do this one for you, but I'm going to ask another
okay.
question. That the later one, I want you to do it yourself. So there are many ways to do this. I'll show you some examples. So for example, a graph of x. Oh, let me use the pirate. A graph of x is a list of x where the first element of the list is the followee. No, sorry, it's the follower, and the rest of the elements of the list is who they are following. Does it make sense?
Yeah. It's kind of like mm, funny that like follower and the person that like someone is following are the same words in Polish.
What?
Yeah,
Re-
yeah.
That is
So
crazy.
when you go on like Instagram, you can like disguise these two. Yeah, these are two like two same like it's the same word, right?
What?
Yeah, yeah.
That's so confusing. So if I walk up to someone, oh, hey, I follow you, I'm a follower. They won't actually know if like who's following who.
Yeah, but the name is of it's uh,
Observe.
spelled obserwujący.
Oh wow, okay, that's fancy.
Yeah,
Damn, okay. Interesting. I did not know that.
yeah.
Okay, so this is one possible representation. Can you give me another
Okay.
representation of this?
Mm. Hmm. Like another way to store this information, right?
To represent it.
Yeah, to represent this information.
Sorry. Using your example, like A to B, B to C, like this example,
Yeah.
I showed you one representation of this example. What's a different representation of that specific example?
Oh, okay.
Yeah, yeah.
Sorry,
So
sorry.
yeah, I need to be more specific there.
Uh,
Okay, I'm gonna get more water while you do that. I'll be right back.
mm,
Okay, I'm back.
right. Uh, hmm. Okay, so mm,
What?
can I like create my own type, my own data?
Sure, sure, yeah, you can do whatever you want. Yeah.
Okay. So like I would create uh hmm,
Oh, I just realized I made a mistake in my graph. It's actually a list of this of X. So it's
a
the
list of yeah, yeah, okay,
where
okay.
the first element of the inner list is the follower. Yeah.
Mm,
You could also do an array of list of X because we know there's a fixed number of nodes.
yeah, right,
But the
right.
inner one can't be an array because it's a variable length.
Mm, okay, so I would do like data mode
Okay.
of X is like a node mm, where it has a name of type X and like where they following
Okay.
of type list X, right?
Okay. It's more
And
formal. Yeah.
yeah, and this would be like a list of nodes of type X, right?
Yes. Yeah. So basically,
Uh,
you turn my inner list into something that's more formal. That's a
yeah,
separation between the person following and who they're following, right?
yeah.
So I would say the one that you have is a better version of what I did just now. Yeah. Okay. So yeah, there are
Mm,
a few other ways to represent this. Um, but let's move on from this. So all this, we call this, the formal term for this is an adjacency list
yeah,
representation.
adjacent, yeah. This
The
is
word adjacent just
is
means next to each
neighbor,
other.
neighbor,
Neighbor,
right?
yeah.
Yeah.
List because well, you and I we see the list, right? We have
Yeah.
each we know the followers of each node. That's where the list comes from.
Yeah, this is how I would like usually store like a graph, right?
Okay, but we saw your competitive programming did not do that. I don't think they did.
Maybe, maybe.
So
Okay.
that's another representation of this, which I believe your competitive programming uses. What is that other representation?
The other representation. Uh, hmm. I can only like think of I don't know if this is a correct way to like uh represent this information, right? A
Okay.
graph. But we could like create a list of edges when we're like edge is like a data that
Hmm.
has like two numbers or something, two x's, and it has like from and to, and
Yeah.
yeah.
So can you give me an example for our graph here on our right?
mm, okay, so like uh, okay. uh mm, hmm. So like can I do this in like uh pirate like syntax,
Sure,
or
sure.
so let's suppose that we have created an edge. Is that this the way to spell edge?
Yep.
Yeah, I think so. So it's an edge from like mm, A A to B, right?
Okay.
Uh, how many edges do we have here? Or so the next would be from B to C, then from C to B, and from uh, B to E. Okay.
Cool. Yeah, this is another possible representation. Okay, I'm not gonna ask you to write out the general sh data
Okay.
representation, but let's say I actually don't know what's the proper name, but I think people call it an edge list.
Edge list.
Yeah. Okay, there is one more representation. Can you think of it?
I heard of uh like a matrix, like yeah,
Yes. Yeah, yeah, okay.
yeah. I heard of that, but I don't know how that works.
Okay. All right, so this one I'll explain to you.
Okay.
How do I okay, I'm just gonna move to the right.
Okay.
Let me draw some lines.
By the way, what's up with the like names of our like characters in this
I think
whiteboard?
it's automated.
Okay.
Yeah, I'm pretty sure it's automatically generated. S-
But it's
These
like always the same when I join.
oh, well, you're an optimistic grouse now.
What is a grouse?
I don't even know, man.
Okay,
I'm
okay.
not gonna lie, I've never heard of that in my life.
Hmm. Okay. Okay. It's some interesting bird. Hmm. Like really interesting that.
1, 2, 3, 4, 5. Crap.
This is gross.
The heck is that? That looks like
Ah,
a turkey chicken King
yeah,
Kong.
Turkey. Interesting, right?
What the? I've never seen that in my life. Okay. All right, so I'll quickly show you what
I can't believe that.
oh wait, I need to change out the names to
Yeah,
wait, can you
I
change the other
can.
side for me? Yeah, thanks.
Yeah, of course.
I see. This session's about to expire. I'll just send you a new link on Gmail in a moment. Like, let me draw this out first. But once it
Uh,
expires, I'll find the link in Gmail.
okay.
So,
We have like session on VS Code.
I mean, I can also do that at the bottom here, sure.
Yeah, what's easier for you? It doesn't matter for me.
Okay. I'll just okay, VS Code then at the bottom of VS Code.
Okay.
All right. So one of these sides say
Mm.
who's the follower, and the other side say who's following. Okay. Uh,
We have less than a minute.
and that A is following. B B is following C. Yeah, yeah, okay. I'll leave it like this for now. All right, I'll send you a new link on the bottom of the VS Code now.
Okay.
Okay, so there are a few ways to go about this. So let me explain
Okay.
what I currently drew here first. So on the left-hand side, we say the follower, and
Okay.
the right-hand side is whoever this follower is following. So
Yeah, yeah, I
if A
understand.
follows B, then like the
Yeah,
check mark on the where they intersect, you say A is following B.
yeah,
And so for B, if B follows C and E, so the second row you see C and E is checked.
yeah,
Third row you see B is checked. So here we have a directed graph. So the arrows, they only point in one direction. So for
yeah, right.
example, you can't interpret like B is following A. Like if you look this way, you might say, oh, B is following A and C, but that's not the case, right?
Yeah, yeah,
Yeah.
mm,
Uh, so in our case, we're looking like this.
yeah,
So with this representation, you might use a 2D array. You might
yeah,
also use
right.
a dictionary.
Dictionary.
A
Interesting.
dictionary, yeah. If you have a fixed number of nodes, typically you will probably be more likely to see an array. I think that's what you'll see in competitive programming.
But can't we like have the same like nodes?
Yeah, so that
Like,
means, oh, I didn't talk about dictionary with you, but you need to have a metric for what equality means.
oh, okay, okay.
Yeah. So you can have like multiple nodes with the same value, but the dictionary needs to know how to compare them, perhaps by object, by their memory
Mm,
address, for example.
okay,
Yeah.
okay. We'll talk about that later, I
Mhm.
suppose.
So if you have a bidirectional graph, what's interesting about the adjacency matrix is that, oh yeah, this is called a adjacency matrix. If you have a
Mm,
bidirectional graph, it's going to be symmetrical across the this diagonal.
quite is interesting, right?
Yeah, so B and E, so like this. So you see that? The symmetry?
Yeah.
So yeah, if it's a bidirectional graph, that's a property of it. Uh, A and B. I think I'll leave it at this. So I believe, actually, I didn't read I just now asked you to show me the code of the graph. I thought it used adjacency matrix, but it also might be edge list representation. I didn't read properly. I think it actually might be the middle one.
What's problem?
Okay, can we go back to the graph problem you showed me just now?
It was with adjacency list,
Was
by
it
the way.
adjacency list?
Yeah, yeah.
Yeah, absolutely sure.
Yeah, I think
Okay,
I am. I did
okay,
that problem, yeah.
okay,
But
okay, all right, okay. Um, okay, I trust you. I trust you.
I can check again. Wait, wait. I won't lie to you, yeah.
Actually, wait, can you share your screen? Yeah, what we're talking about, I guess we can talk about how they choose to represent it. Because if I'm
Because
not wrong, I saw one use an array, another used a vector, which I found interesting.
uh, mm,
Adjacency.
yeah, it was a list
It's a
like
list. Okay,
just
adjacency list.
yeah.
Okay, wait, can you scroll to the top? Can I see the type? Was it an array of vectors?
No, it was a vector. What it was? Yeah,
Array of vectors. Okay,
yeah.
array of vectors. So I'm guessing like this LL is the index of the array the follower.
Mm,
You get what I'm saying?
yeah,
Can we
yeah.
control F adjacency C? Oh wait, I think line 22 for you auto adjacency V. So that the yeah, I think the index of the array is the follower.
Uh,
You see that?
yeah, yeah.
So V is a node. They associate nodes with an integer here. So it's asking who's the neighbors of V. It says, okay, let's pass that into the array adjacency V. Get me your neighbors. And so adjacency V gets the neighbors. You see that?
Yeah, but this is an undirected graph, right? So
Okay. Okay. Let me think about how I want to do this. Do you know if, can we see the other file? Is it the same?
like this, yeah, I
Yeah.
suppose.
Can we look at L? What did they call it L? Like list? Yeah.
Ah, yeah.
Yeah, okay. 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 There's one thing I want to talk about as well, which is that a tree is a special purpose case of a graph.
Okay,
A tree has no cycles.
right.
So pedagogically, I separated tree from graphs. I told you about trees first because the fact they have no cycles makes them possible to recur easily. You can do structural recursion
Yeah,
on them.
yeah, yeah.
Let's let's talk about graphs now. I think it's time. Okay, you can stop sharing your screen and let's go
Of
to
course.
our new file, graphs.arr. Okay, I would like you. Hmm, should we? Let me think about this. Do I want to do this in C++ or Pirate? For now, I want to stick to Pirate, but I think we're going to make a big move to C++ real soon. In Pirate, I want you to learn about arrays. Do I want to do
Um,
that? Yeah, I think let's do it. So pirate arrays are essentially the same thing as C++ arrays. The names are a little bit different, but for all intents and purposes, they're the same thing. I'm going to send you the docs over here at the top. Have that open. Let's pull over some sample code just so you can see what it looks like. Oh, no way. Do they not have the square bracket syntax?
uh,
Damn.
the syntax is uh,
So I'm gonna copy. an example over. There we go.
Wow, it's really ugly.
Yeah, I don't. Okay. The reason why I want to use Pirate first is because the testing is built in.
Yeah, yeah.
That's
So,
basically it. I've pasted in some starter code just so you can get an idea. When you're testing, use the squiggly line. The squiggly line is uses structural equality essentially. Sorry,
like
extensional equality. So it looks at the contents of the array.
s- s- what line like this?
Yeah, tilde.
Oh,
The
oh yeah, you could just set tilde. Okay,
sorry, I
it's
prefer to call it
it's
squiggly line.
it's
Okay.
tilde in Polish. So
Oh, okay, okay. Yeah, it's funny because when I said tilde, I was expecting it to be a completely different word in Polish.
yeah, yeah.
Okay, that's funny that it's the same. Okay. All right. I want us to use a representation that your competitive programming uses. Typically, I would tell people to be familiar with all of them, but for us, let's just stick to one, which is the adjacency list. Can you write the data definition of our graph? And I want you to copy the way that your competition will use.
Mm, can you say that? Can you say that again?
Oh, write the data definition of our graph
Oh, of course.
and use a
So,
representation that's similar to how you do it in the competition.
mm, like, okay, okay. With like adjacent lists. Okay.
Yeah, yeah. What we did in
Mm,
Excalibur, you did one version,
yeah,
but that version is quite different from what you did in the competition, right?
yeah, right.
Yeah.
Uh, mm,
Uh,
with like with arrays, right?
yes. All right, I'm gonna let you do this. I'm gonna use the restroom. I'll be right back.
Of course. Oh, uh, uh, hmm.
Okay, I'm back.
Okay. So uh, I haven't done much. I
It's
just
okay.
thought about this.
Thinking is good.
Is this array of arrays, right? What it's small. Okay.
Okay.
Okay. Uh,
Can the inner array be an array? So the inner array is like the adjacency list itself, right? It's the list of neighbors.
Yeah.
Should that be an array?
Hmm.
Like, what if one guy has a lot of neighbors and one guy doesn't have any neighbors?
What?
Yeah, what happens if so the inner array, that's the neighbors, right? The neighbors list.
The neighbor, right? Yeah.
What happens if one guy has a lot of neighbors, but another guy has no neighbors?
Yeah, what about it?
Do we want to use it? Given that that could happen, do we want to use an array?
Yeah, why not?
Okay, that's fair. We could use an array, but in your competition, I saw that you use a vector in the middle as the neighbors.
Yeah, right.
So no, I feel like we should use list, right? Which is our version of a vector for the inner array.
Wait. Mm, okay, I suppose we can. Okay.
But honestly, you could use both, but I think a list is more appropriate here.
Okay, okay.
Yeah.
We need to create some examples, right? Mm.
Yeah. I would also leave a note that the index of the array is the
Oh yeah,
follower, right? So yeah, we'll leave a note. So this is not enforced by the
yeah.
data representation, so we have to add a comment on this. So this is the weakness of the representation. For example, like what
The
happens if you have a -1 node? That's impossible, right?
yeah, right.
Yeah.
Hmm. Very interesting. Is the uh mm, how to say that? Is the value and uh how to say adjacent?
Yeah. You can just
Uh,
write ADJ. That's fine.
okay,
Cool.
okay. Cool,
I would
cool.
also say that nodes are represented as numbers.
Uh, okay.
Okay. I
Like
wanna, yeah,
quick example, okay.
sure.
Mm, what would be a good example? Maybe one points to nothing, like nothing.
I would actually
Okay.
start smallest. Like I would always begin with the smallest possible example and then
Okay.
work your way out. So I wouldn't jump straight into a more complicated example. Okay, also I want to pause here because
Yeah,
I
you
want to
have.
introduce some other
Okay.
ideas
Okay.
about how we can represent this. But
So
we're out of time now, so we have to resume
no
tomorrow.
homework today.
Um, I would say if you can, please read more graph problems for your competitions and
Oh,
see
okay.
if you do you have access to other people's solution? Like do people post them online?
Uh, I have like access to all these solutions from the Polish Olympiad because it's
Okay.
on the website.
Can you compile them into a folder and we can go over them together?
Like only graphs, right?
Graphs and trees. If they treat the trees like graphs, that too.
Okay.
Yeah.
I can do that for tomorrow.
Awesome. Okay. All right. We'll catch
Okay.
back up tomorrow then. All right. See you,
Yeah.
Simon.
Thank you. See you
No
soon.
problem. Bye bye.
Bye.